Hi everyone, this is me Mahesh. This is going to be first video of our channel. So what we're going to cover in this video is one problem flying blind 75 series. We'll make video every single day on this 75 problems. So each and every day you can see one problem from that blind 75 sheet. And then if it's going good, then we can just continue and we can move on and solving some more problems also. As a start, we'll go with this blind 75 sheet. You can ask me why I should see this channel. And actually I don't have answer for this. Yeah, there is a lot of other great content creators are there who already made video on this. But I just want to improve my communication skill as well as my explanation skill. That's why I make this video. I hope I might give some additional or at least 1% extra knowledge from what they have given additionally. So let's see how it's going. So as a first problem, we are going to see a content duplicate. If we read a question, our problem statement, it tells that you will be given a list of number, and you just need to tell whether it has duplicate or not. This is pretty simple problem. As the first problem, we'll go from easy and then level by level we'll go. So if you see the given input, will be given array of integers, and you have to return true or false. True in the sense it has duplicate. If it doesn't have any duplicate, you have to return false. That's basically simple input and output which is given by them. And then we have multiple solution for this. We'll start from the brute force approach and then we'll go for a better and then we'll go for optimal. We'll see three solutions in this video. If we talk about brute force, it's just simple. What you have to do is you have to pick an element and you have to just compare with every other element whether it's equal or not. If it's equal, we can just directly return true, indicating that this array has a duplicate number. It's a pretty simple solution. Just put 2 for loop and just compare ith element with next element and next element, which means every other element. If I want to write a pseudocode, I can write a pseudocode for you guys. Like for, we'll start from 0. It's going to be pseudocode. It's not going to be any language specific. You can just write on your own language. This is just a pseudocode. We'll go from 0 to the n, and then we'll put another inner loop and we'll go j, which is going to from I plus 1. If you take this element, you have to start seeing from the next element, right? So we'll go from I plus 1 till the nth element. So what you have to do is, if array of I is equal to array of j, if this is there, and then you directly return true. If not, just return false. Simple. It's very simple solution. But if you see the time complexity, TOC is going to be of n square. This is going to take n time, and then this outer loop will also take n time. If you just multiply it, you're going to get of n square. And if you take space, obviously we are not using any kind of space. This is simple of linear space. And then we can just do some better and we can reduce the time complexity. If you take a problem, optimization can be either in the space or either in the time. You cannot decrease both the thing. In some case you can do, that is a special condition, special case. But if you take optimization, you just want to give up on something. Either it can be a space or it can be a time. You have to give up on something else. You cannot do better on both. Either one will be better, one will be a normal. Like that you can do it. You cannot do both as optimal. In some case you can do it, but not at every case. So if we talk about The better solution, what we can do is, instead of comparing one element with every other element, which takes O of n square time, we can sort the array. We can just sort the given array. You can just compare the current element with the next element. That will easily gives us whether it has element or not. What I'm telling is, let's take an example like, I'll just use a different color. 1 2 4 1 8 9. Let's say assume this is a given input. So if we just sort it out, 1 1 2 4 8 9. So if we sort things out, the duplicate element will come next to the original element, right? If we sort. So if I just compare 1 with the next element, you can easily find the duplicate. You don't have to compare with every other element. You can just compare with the next element. If you compare 2 with 4, which is not equal, which means it don't have any duplicate. And if you compare 4 with 8, no duplicate. If you compare 8 with 9, no duplicate. But if you compare 1 with the 1, it tells that you have a duplicate. So if we sort the array, we can improve the time complexity. So now our time complexity will be n log n. Basically, this is for sorting. And if I want to write pseudocode, I can just write it for you guys. We can just go to I and n minus 1, because we're just comparing current and next element, right? We just need to go one element before. We can't go up to the n. So it's just a simple thing. And I can just compare if array of I is equal to array of I plus 1. And then if there, then return true. If not, return false. Again, this is outside of the loop. If I want to just give us some simple try run, what I can do is, this input is so simple, we'll take some other thing. Instead of 2, we'll put 9. If we sorted 1 2 4 8 9 9, this will be our sorted input. For better dry run, I just took this example. If I take a previous example, it will just finish very easily, because on the first try we'll get this thing. So we'll take this example. Now our pointer will be at this position. So we'll compare this with this. No, it's not equal. Again, we'll go to the next. 2 with 4, it's not equal. Again, we'll just move next place, and we'll compare 8 with 9. No, it's not equal. Again, we'll compare 9 with 9. Yeah, it's equal. So we just directly return true. This is what the better solution looks. Again, we can improve this a lot more better than this, which is using hash data structure. We can use hash map or set. We can use any of those things, and you can reduce the time complexity from n log n to the O of n time. This is way much better. You can see the pattern, right? You just optimize from O of n square and O of n log n and then O of n. If you see, you just focusing on one single thing. You are not focusing on space. In this example, we don't have much things, but if you take a different example in future, we'll see, right? We can see at the time. You can either just focus on only one thing, either a space or a time. That's what the beauty of problem solving. You have to just give up on something else to get something better. You can give up on time or space. That's why you will see TLE, which is time complexity, and MLE is memory limit exist. You just want to give up on something else, then only you can get a better result. If we seeking for two things, that's not going to happen in all the case. Okay, without talking much, we'll see the better solution. Sorry, it's an optimal solution, right? We are talking about optimal solution. So I was talking about hash map, right? So what the basic idea is, I can just put the element whichever I seen to the hash set. We'll take a same example, which is 1 2 4 8 1 9. We'll take this simple example as an input. So what we are going to do is we're just going to iterate every element, and we're just going to check whether this is present in our hash or not. If it's not present, we're just going to add it to the hash, or you can use set, anything. You can directly add this to the set, and then we'll just move to the number 2. 2 is not present, so add it to the set. We'll use the set here. We'll use the set here. So we're just checking 1 is not there, so we're just going to add 1. I use hash map here, which is I am good with hash map. And then you can use set or hash map, anything. Again, I'm just moving to 2. I'm seeing 2 is not there, so I'm going to add 2 to the hash map. Again, I'm just going to 4 is also not there, add it to the hash map. Go to 8 is also not there, add it to the hash map. And sorry, should be 1. This should be 1. And if I go to the 1, I already have 1 in the hash map or asset, which indicate that 1 is already exists and you don't have to add again. And this tells us that you found a duplicate number in the given array. It's so simple. If we came from brute force and to the sorting solution, we just came to the best solution for this problem is using set or hash map. You don't have to iterate anymore, you directly return false. Again, if I want to, I'll just write pseudocode for this also. Again, this is a choice. You can use set or else hash map. If set is so simple, you don't need to maintain any kind of frequency. It's going to be 1 2 4 8. When you try to add 1, the set will tell that you have an element already. So basically, set is a collection of unique items, right? So it will automatically tell us that it's already present, you don't have to add it anymore, and this is a duplicate number, so you can just return duplicate. Okay, I will write the pseudocode for this. We just define the set. Set is going to be set or hash map. We use hash for better understanding. Then for num in nums, basically this tells that pick every element from the nums. This is what the syntax tells. I'm just checking if number in set, if it's already there, you just need to return true. If not, just add it to the set. Set dot num is going to be true. If nothing happens, return false, which tells there is no duplicate. This is a simple solution. That's it, guys. We have seen all three solutions, starting from brute force to the better solution to optimal one. And I know that I'm not that much good at teaching, but we can improve video by video. And thanks for watching till this end. I will give timestamp. You can just jump upon 3 different solution. You can see if you want optimal solution, you can directly jump to this. So we'll improve our explanation day by day. So thanks for watching, and we'll meet again next video. Until then, bye.